which is the order from most acidic to least acidic of these four compounds. So right, how do we determine acidity? The stronger an acid, the more stable its conjugate base. So that is because the logic behind that, if the acid drops off a proton, right, becomes its conjugate base, the more stable that conjugate base is, the less likely that dude is to pick that proton back up and turn back into the acid, right? So the more H plus will be in solution at an equilibrium, the lower the pH will go. So the stronger the acid, right, the more stable the conjugate base. So let's deprotonate these guys and see which one's the most stable, right? So here we would drop that off, put a minus charge here. We could drop one of these guys off, put a minus charge here, right? So we know, you should know right away that one is going to be the least acidic, right? And I believe it is chapter 18. You saw about deprotonating carbonyl groups at the alpha carbon, right? Here's alpha, here's alpha, here's beta, right? Here's alpha. So we saw that is something that can be an acid. This guy is like about as weak of an acid as can possibly exist. So one will definitely be the lowest, but let's compare these. So the more we can delocalize this minus charge, the more we can show that this is stabilized through resonance, right? So let's draw this guy out a little better. C, H, H, minus, right? So we could go here, here. That would end up with a minus charge up here, here. So we delocalize that negative charge a little bit onto an electronegative oxygen, right? We formed an enolate, right? I believe enolate. An enol. Yeah, an enolate, yeah. Okay. So that dude's alright. Let's look at the other guy. Okay. So this, what was it? CH2, HH, lone pair minus charge, right? So same deal. We can go here and here, minus. So we can delocalize that charge a little bit by forming a double bond here. But also, so this guy also has the ability to, through resonance, to go here, right? So another resonance form would be if I just dropped a double bond here. I'm sorry, that's totally bad, right? Right there. We drop a double bond there, and then we can no longer have a double bond here. So basically, this O and this CH2 minus of the conjugate base are both competing to delocalize their electrons onto this carbonyl carbon, right? So this basically is adding electron density to the already negative guy right here. So it, let's see, increases the instability, or I should say decreases the stability of this conjugate base, making it a weaker acid, right? So this guy is definitely going to be less acidic than this guy. Let's look up here, right? So we had C, H, here, minus charge. Let's go. So for these carbonyl carbons, alpha carbon acting as acid, anytime you got two carbonyls on the side, it always increases the acidity. So this is like if we added another carbonyl group after this carbon, we'd increase the acidity by a lot. Same with this guy, right? If we added, say, a ketone, another ketone, if we had a diketone or something, this would be a lot more acidic. Okay? So that's key. So this is going to be the most acidic. Let's see if we can show it through resonance. Okay, so right, We could delocalize it to the left, right, and get a minus charge there. We could also delocalize it to the right, right? So we can withdraw electrons to both sides, okay? Yes, this side also is going to, just like in 4, have the ability to go here and make it a little less easier to delocalize these electrons to the right as it's easier to the left, but still we can delocalize this minus charge to both sides of the molecule, right, and disperse basically the electron density away from here, away from this carbon. We don't want too much electron density on a not very electronegative carbon, right? So that increases the stability, the ability to delocalize these electrons to both sides, increases the stability of that conjugate base a lot, making it a stronger acid than both 3 and 4. So let's see, 1, 2, 3, and this guy's 4 in that order. So we're going to have 2, 3, 4, 1 as our answer. 2, 3, 4, 1. C. Right? 2, 3, 4, 1. Okay.